All right, so welcome to OWASP Los Angeles January 2022 meeting. We're glad to have you. This is one of the biggest chapters in OWASP, and we used to have a regional conference every year in Santa Monica called AppSec Cali, which unfortunately because of the pandemic has been being postponed several times, and we're hoping once the pandemic dissipates and it's manageable, then we can probably have an in-person conference started back up at some point. But for now, we're just continuing our monthly meetings through the Zoom meetings. Please make sure that you sign up for the notifications out of Meetup. We announce them in Meetup, and if you RSVP, you would see the link to the Zoom meeting within the invite itself. So, let's see. So these are the board directors for OWASP Los Angeles. Although we're doing these meetings in Zoom, it takes a lot of preparation, and also we are always looking for speakers. So if you have suggestions or you know somebody that has a relevant speaking topic, please let us know, and then we'll coordinate with them for our upcoming monthly meetings. I'll start this video. It's really short, so bear with us.
It's a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100+ active projects, and new project applications are submitted weekly. Projects are open source and are built by our community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections, and recently, OWASP added a brand new They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections, and recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today. It's a nonprofit that stands for the Open.
Okay, so it's sometimes difficult to get out of that screen. Basically, right now the main methods of communicating with us is through OWASP Los Angeles Meetup channel. We're on LinkedIn. We have limited activity on Facebook or Instagram, but we're active on Twitter. All these recordings will be also posted in our YouTube channel. So please, if you know somebody that wanted to attend and they missed the meeting, they can always watch the recording after that. And the entire 12 sessions from last year is also already posted. Membership, there was a short notice about that on the video, but these are some of the biggest items that I feel is really beneficial for us. Just go to OWASP.org and you can click on the links and just attend the meetings, attend the free training. There's tons of projects that you can use during your work that benefits the security of your applications and the environment. So take advantage of those. Membership is only $50, so it's not that much money, but your contribution goes to a lot of good work that's being done by OWASP Global and its chapters. If you're a student, it's only costing you $20, so there's a lot of good value for only $20. Just a notice that February 22nd, it's going to be the OWASP Career Fair, the entire day, Eastern Standard Time. Just go to OWASP.org events and you can do interviews, resume workshops, etc., the whole 9 yards. Really good opportunity to take advantage of it if you're looking for a new job or you're just starting your career in cybersecurity and application security. If you're a sponsor and you can sponsor, please contact us. We would love to work with you. We have over 2,400 members in our meetup channel, so a really good value and good exposure, especially for Southern California, which has a lot of members throughout California. As I mentioned, for our AppSec California, it was, I think, 6 or 7 chapters out of California that contributed to put that together. So you'll reach a really large audience in Southern California. Next month, we have our talk by Robert Hansen, known as RSnake. The title is about, it's a NAN issue. So details available in Meetup. You can go and take a look at it there. And with that, Matt, take it away. Mic is yours.
All right, thank you very much. Let me share my screen. After I steal the screen from you.
You're welcome to do that.
Yeah, so hopefully you should be seeing some onions.
Yep, we do.
Awesome. So, welcome to the OWASP LA chapter meeting. I'm Matt Tesaro. I'm going to be talking about my, I don't know if I made the best choice in naming, but I called it Peeling the Onion, Making Sense of the Layers of API Security. Quick overview of what we're going to do. I'm going to have a quick overview of APIs in general, a very fast overview of APIs in general. I'm going to talk about API security and my sort of view of it. I'm going to run through what I would call the API security landscape, then change gears and talk about API security concerns, and then finally have the traditional takeaways, etc. And I have the chat window open. I have an ultra-wide monitor, so I can see way more than this presentation. So if you guys have questions, feel free to ask them. I can take them during the talk or after the talk or whatever. I'm pretty flexible. I've done this a few times, so you're gonna have to work at knocking me off my spiel. So overview. Let's do a quick overview of APIs in general, what they're about. Right. Oh, and API security in particular, this is just my own personal statement. It doesn't represent me or my work or any of that other hoo-ha you were supposed to say. But I do believe that API security is different enough from traditional AppSec that it kind of needs some special attention. There's tons of overlap, but there's enough that isn't overlapping that I think that's where we sort of need to focus. And I also believe APIs are only going to grow over time. Any kind of numbers you read about the growth, it's crazy big. What was it? Oh shoot, I think Google with Apogee had like 85% increase year over year of API traffic on the internet. It's just nutty, and it's just going to get more nutty. So this is a good subject to be listening to. So who am I? Who's this guy? I like to call myself a reformed programmer. My first job out of college was actually writing web apps forever ago. And I kind of morphed into the security space after doing a lot of pen testing, consulting. And then I kind of went internal and did a lot of product security and AppSec inside of companies. I'm currently working for No Name Security. I'm the distinguished engineer at No Name Labs. I have 14 years of knocking around the OWASP community. I started in 2008. I'm one of the core maintainers of OWASP Defect Dojo. I'm a co-leader of the OWASP AppSec pipeline, and I'm the leader of OWASP WTE, although honestly, that project is kind of dead. It's mostly there for archival reasons. I have 22 years of using Floss and Linux. I'm very much a Linux fanboy. Quite honestly, the last time I ran a Windows version, or even a Mac version for that matter, when I had a choice, was 2000. So I'm a Linux guy. This is coming to you from Linux, so go Linux. I'm also a Go language fanboy. That's what I'm writing everything in when I get to write code these days. And then that's a picture of me 2.5 years ago, 3 years ago almost. And I guess April will be 3 years ago when I got my Idan and Tong Sudo Migu Kwan, which is a 2nd degree black belt. And that kick scared the crap out of me. I was quite certain I was going to land on my backside, but I didn't, so hallelujah. And I'm also a founder of 10 Security. So APIs, they're simple, right? You go pull it up on Wikipedia, the first sentence, right? An application programming interface is a connection between computers or between computer programs, right? You have your program, I have my program. I don't really care what language your program's in. You don't have to care what programming language my program's in. You make a call to get something and I give you something back, right? APIs, they're simple, right? This isn't hard. Well, actually, APIs simply are not simple. There's way more than just this simple representation in the previous slide. You have to consider the type of APIs, right? They started out years ago with XML RPC, then SOAP, then REST. Now we have gRPC, we have GraphQL. There's a whole bunch of different types of APIs. The transport is generally HTTP, but there's multiple versions of that right now. The encoding can be XML or JSON. There's several different binary encodings the data can travel in. And then you have the infrastructure that supports the APIs, right? You might have a load balancer or an API gateway, some kind of control plane to manage your APIs. There's a whole bunch of pieces here. And then stakeholders, right? Depending on what kind of work your company does or the business, right? You might have multiple stakeholders involved in the APIs, definitely the product teams and the developers. You likely have network admins, if nothing else, getting traffic to your APIs. InfoSec and AppSec will have a role to play. If you're using an API gateway, you have those admins. There's a ton of people involved in this. So APIs are very deceptive. They seem like a simple thing, and conceptually they are rather simple, but in practice, when you're actually doing these things for real, they're quite complicated. And if you don't believe me, go to API Landscape, which I also have open in another tab right here. And I can scroll through all of the companies that have a piece or projects that have a piece of API, the API landscape. These are all players in the API world in various different ways. So this API thing is kind of nutty and kind of busy. So you don't have to believe me. You can believe a random website I just showed you because, you know, everything on the internet is true. Another thing about APIs, they're going to grow over time. You get the first little taste of an API and you want more, unfortunately. So there's two sort of growths that happen in API. You have what's called breadth growth, right, where you add more and more API endpoints. And then you can also have depth growth, which is where you have APIs that sit behind sort of those first layer of APIs that take, so that when I make a call to an API, it's making a call to a different API, who's making a call to a different API, rinse and repeat. Particularly in things like microservices, you're going to have a lot of this intra API or API to API communication happening. And then you'll also hear terms about cardinal directions in APIs, which at first confused me. Turns out that north and south is really any traffic that originates outside a data center, whatever that means these days, like a VPC or something, right? But usually public, let's say if you have a publicly exposed API, that sort of first layer of traffic is called the north-south traffic. It's from outside of an organization into an organization, typically through an API gateway. And then east-west traffic, if you hear that term, that's talking about traffic between internal APIs, stuff air quotes, inside the firewall or inside the data center, again, whatever that means, right? Really in a VPC or something that's internal. There we go, my pointer stopped. Okay. Okay, so let's have a better definition of what an API is. And I think particularly from a security or security controls point of view, you need to think about APIs a little bit differently. Really, an API is three things. It's a method. Is it get, post, put, delete, patch, right? One of those HTTP methods. It's a host name and it's a path, right? There's three of those things happening to make an API. And particularly from a security controls perspective, the reason you need to take this definition is because a get HTTP method sent to example.com v2 users all is nothing like a delete sent to that same endpoint, right? One, you get a list of users. Two, you say goodbye to all your users. Two very different things, two very different security concerns. One path and host name, right? So you need to take all three into an account. And same thing, adding an admin in that second example, a post to uat.example.com, right? Adding an admin in UAT or a pre-prod environment is nothing as scary as adding an admin in production. So one of the things that really, when I started getting thick into the API world, I really kind of learned was you can't think of APIs just as methods tacked on the end of an URL. The actual verbs or the methods of HTTP make a big difference. Okay, API security, and I need to take a drink. Of water. So I'm going to do a very quick overview of it. I'm sorry?
Sorry, Matt. I was just saying you're rocking it, man. Doing a great job.
Okay. I got a little dry mouth there. And not California legalization type of dry mouth because I'm in Texas. So API security. We've got a quick overview of that. And hopefully your API security does not rely on an old hermit out in the desert who has force powers, right? You do not want to just pretend that these are not the APIs you're looking for, because trust me, if they're on the public internet, they'll be found. So I like to define, and for the purpose of this talk, I'm defining API security in this way. API security is how you determine or figure out the state of the security from three different perspectives. One is what I call security posture. The other one is runtime security. And the third one is security testing. And hopefully that testing is continuous. I'm kind of into the CI/CD thing. So let me further explain. So what's API security posture? It's getting a broad view, an overview, inventory of all of your API landscape, right? Particularly the API endpoints, but also I would include gateways, load balancers, anything that makes those APIs happen. So the first and foremost is getting that inventory of every API. And I mean by the definition I said earlier, where you have host name, path, and method, HTTP method, right? And then you need to understand, are those APIs going through a gateway or not? If they're not going through a gateway, are they legacy APIs? Are they east-west internal only APIs? You need to understand sort of what purpose those APIs serve. And then once you have a list of all the APIs, the sort of next step would be to map the data going to and from those APIs, right? Understand that this particular call to, I don't know, users includes PII, but a call to preferences may only say that I like dark mode versus light mode of the app, and who really cares? So understanding what data is going to and from those APIs and then classify them, particularly in terms of sensitivity or maybe regulation, depending on your industry. And so this is, I like to think of it as the who, what, and from where of APIs is what security posture should answer, right? Who's calling those APIs? What data are those APIs sending and receiving? And where did those calls originate, which is really, are they publicly exposed or internal APIs? And then API runtime security, that's understanding what normal is for the running of your APIs, right? The whole idea of security, right? If you don't understand normal is, how can you understand what abnormal is? This is what runtime security gives you. So it's watching or inspecting the traffic to and from all of your APIs. This can be done inline or out of band, kind of, dealer's choice on that, what works better for you. And obviously this inspection not only has to understand network packets flying around, but it's got to understand all the types of data or types of APIs that exist, right? Is it a REST API? Is it a gRPC? Is it a GraphQL? Those have different behaviors from a network perspective and from a data perspective, right? So whatever you choose to do this with has to understand all the different API methods that you support. And now that you have a view of what's happening in terms of traffic, you can start doing interesting things like modeling that traffic, right? And do anomaly detection, right? This could be heuristic, this could be ML, you could have some magic AI pixie dust happening, whatever it is, right? You have a way to understand that this is not what I normally see for this API. Like, why is this API that suddenly usually has 100,000 calls a day has 3 million? Something has changed, right? And as you're watching that, ideally, you're continually learning new methods in which the APIs are interacted with, right? If there's a spike, it may be a legit spike, right? Maybe it's Black Friday, maybe it's not Black Friday and you need to know. And also maybe there are new APIs that made it out to production that you don't know about. So they're not in your posture or inventory, but they are actually publicly available. Like, this is a good thing to learn, right? And this is something the runtime side of API security can tell you. And then once you have this sort of behavior-based modeling and the ability to inspect, now you can do interesting things like set thresholds, right? Is there abnormally large traffic? Is there suddenly a tripling of volume of data going into or out of an API? What's happening with that? And you can set thresholds to do some sort of alerting, which allows you to respond to those in several different ways. The ways I've seen is a manual, right? I just pop up a little thing in a web console somewhere that says, oops, this looks bad. Probably not the best one. What I would call manual would be I set an alert that drops a ticket into Service Desk or Jira or whatever maybe a SIM, whatever your thing that tells a human, hey, go triage this potentially scary looking event, and let's see if it's worth acting on. Or maybe you have it, I would call that semi-auto. And then automatic would be, you break a threshold, I de-auth your JWT, and you can no longer talk to the API, right? That would be like a blocking action. Or maybe I see a call to an API that should only be internal, but it's coming from external. I talk off to a firewall and set a rule to block the IP of my internal API, or maybe make a change to an API gateway. Kind of depends on how you have it set up. But this allows you to do blocking, geofencing, all those kind of things. And then API testing. This is, it's what it is, it's testing. It's like what a lot of us AppSec people kind of know already, right? This is how you assess the security of a running API. But in my case, I really don't tend to include SAST or static analysis or looking at the source code as part of API testing. You still need to do it. It's still very useful, but it's not special, right? Looking at source code for source code flaws isn't radically different if it's a traditional web app, if it's even a desktop app, or if it's an API, right? You have a SaaS tool that does its thing, you get results, you deal with it. There's nothing super special about APIs, or at least the API code that powers them. I'm really focusing on DAST. And bonus points if you have a DAST that allows you to do that in a continuous or CI/CD manner, right? So you can hopefully stay up to speed with what your devs are doing. Now, to do this testing, it gets pretty interesting. I back in the dark ages, when was that, 8, maybe 9 years ago, I started the product security team at Rackspace when Rackspace was really pushing OpenStack in their cloud, right? So if you're doing product security for Rackspace that has a cloud product, you test zillions of APIs because we had loads of them, right? And one of the biggest problems in those early days of API testing was we didn't have Swagger or OpenAPI or any kind of spec file. So just figuring out how to talk to an API could be interesting. It was like read the docs and figure it out, right? At least now we have these things like Swagger and OpenAPI, which are specifications that say, This is how you talk to the API. This is the data I will require of you, and this is what I will send you, right? So you can do that. You could also look at recorded traffic to understand how APIs talk. And bonus points like +1, if you already were doing runtime API security and you knew what that data looked like, you could actually do attacks based on the traffic you've seen, right? And that kind of automates the process, which is pretty cool. Now I don't have to upload a Swagger spec. The tool already knows it. And then once you have results, obviously the next step in the process is to figure out who do we send those to, right? Let's get this thing addressed. I have found a vulnerability in this API endpoint. I need to get it fixed. So you'd want to submit those to wherever the developers talk, which is usually some kind of issue tracker like Jira. Ideally, you'd want to be able to see the vulnerable requests and responses. So if the developers have questions or pushback on the fact that, no, this really isn't vulnerable, you have some sort of proof in terms of HTTP request responses or whatever the communication mechanism is, right? And then ideally, it'd be really cool if whatever tool you select has the ability to poke a button and retest that specific issue, right? Because if you've ever dealt with sort of working things from finding a vulnerability to getting it mitigated or remediated, retesting is a big part of that. Can you explain the recorded traffic? Are you saying you should compare the normal expected traffic? Yes, in some way. This is a great question. The idea when I say recorded traffic is you have a method to watch all of the traffic going to and from the API and be able to inspect it. And like I said, this could be inline or out of band. But the big thing is I can see what's going in and I can see what's going out. And if I'm doing that, I have recorded traffic. Now you could also do this in a very, very old school way, like pull out Wireshark and record a PCAP and look at that traffic, but that's really low level and manual and won't, if you have any kind of number of APIs, that won't be scalable enough to get you there. So really recorded traffic would be, I've seen that traffic, it's gone through some kind of network device, ideally that understands what APIs are and has that traffic for you. Thank you for the question. And I said all that about retesting. Okay, perfect. Whew, okay, so API security landscape. This is all of the parts that make up an API ecosystem. And I've got in the next slide, I've got an example. This example is one of 10,000 examples. There's probably as many API or ways to roll out API or do a deployment as there are grains of sand on your favorite beach. So understand this is just conceptual. Oh, whoops, I'm ahead of myself. I'm off by one. So you got to remember the great Shakespeare quote, all the world's a stage, excuse me, all the world's an API and all the men and women are merely stakeholders. It's not quite exactly what Shakespeare said. So here's the stage, right? At this far side, we have a user talking through a WAF to a web API. That web API is going to make calls in through a web gateway that's going to talk to a whole bunch of backend services. You could also have a mobile app going through that API and talking to mobile services or some of these other generic services. You have some kind of control plane to manage this API gateway. And you may have east-west traffic where some services may call back to a shipping service or a payment service. Those could be in AWS or Azure or on-prem or wherever, kind of doesn't matter. But this is to give you an idea of the moving parts of an API landscape. So all of these pieces kind of, oh, and the IDP is the identity provider. If you're using that to do authentication of your users and potentially authorization too. So this is your API landscape, at least a generic one, right? Yours may look different and your mileage may vary, but this is a good sample if nothing else. So let's break down the landscape. So the WAF, who do you have to talk to if the WAF is part of your remit as an AppSec person who's doing API security? Well, network ops likely runs that. You may have an AppSec team or an AppSec engineering team that may run that or at least write rules for it. You're going to have product teams that are going to have a lot of claim into that because that is in front of their product and they don't want their product broken by the WAF. There's also the web app, right? And the stakeholders there are the product teams, the AppSec for sure. Marketing may have a place in there. For the mobile app, you may have a different mobile and product teams, or you might have one team that does both. I've seen both in my time at different AppSec groups. Obviously, there's AppSec there. There's probably marketing. There may be sales if you're selling with your mobile app, right? Bunch of different stakeholders. Same thing for the IDP. There would be an identity and access management group or team or something. AppSec, InfoSec. The API gateway, you usually have gateway admins. Product will have a role in that. AppSec will have a role in that. APIs, right? The product teams and the developers definitely have a role in that. AppSec has a role in that. Marketing, sales may have a role in that, right? So all those to say is there's lots of chefs in the kitchen of API security, right? It takes some politicking and some working between groups to make sure that they're all on the same page and they're all sort of rowing in the correct direction to make sure you actually end up with a secure API. You can focus on one little area, but there's so many different stakeholders, you really have to have a broad remit. Oh, and then things that didn't make the diagram, right? Cloud, if you're using cloud, you probably have some kind of cloud admins or a DevOps team or a DevSecOps team that manages your cloud infrastructure. They're gonna have a piece of this. Product will have a piece of that cloud. If their products are deployed to the cloud, AppSec will be there. Finance may be there because they don't want you to overspend for cloud. And then presumably you have some kind of SOC, right? Security Operations Center who has an IR team who's kind of minding the store generally for the business. They're also going to have a role to play here. If there are incidents with the API, if there's downtime, if there's attacks, what have you, right? They're also going to play a role. So those last several slides were all about, hey, there is tons and tons of people who have a finger in the pie, and you need to make sure you account for them when you're doing this API security work. Whew, okay, API security concerns. So these are items to consider when securing your API. I got to take another drink. Whew. Okay, and I had to do it. I apologize in advance, but API security is like an onion, lots of layers. So let's talk about some of the layers. And I'm going to go through some attack classes. These are very high level attack classes. And usually the attack classes, when you talk to people, things they're concerned about with APIs. And then for those attack classes, I'm going to talk about how the three different sort of perspectives of API security play a role or don't. And so DDoS or distributed denial of service attacks, right? You have your traditional ones where I just send you ridiculous amounts of SYN packets or some such thing where I flood you with traffic and try to knock you offline. Fortunately, is that the right way to say this? Let's just say, fortunately, those have been happening for a long time. And the controls to handle those are pretty standardized. Like if you're a larger business, it's likely you have something to mitigate traditional network DDoS, particularly if you're online and that's an important part of your business. HTTP floods are a different thing, right? This is what looks to be like legitimate traffic, just ridiculous amounts of it, right? So this can be a lot trickier to block because whatever is doing that inspection has to understand, hey, yes, this does look like a legitimate post or GET or what have you called to that API, but I'm getting zillions of them. It's time to pump the brakes on this. And this could be something malicious, which is, you know, an attacker trying to knock you offline, or this could just be a single customer or client, depending on who's using your APIs, that's over consuming, right? If you have one of your customers that's using 90% of your resources, that's not particularly fair for the rest of your customers. And then application level DOSes are some kind of consumption attack where I try to eat up as an attacker all of your CPU or RAM by making particularly intensive calls. You can do this kind of stuff. When I used to do pen testing, this was the fun one to do because you'd find calls that seem to take a lot of time to respond and you just make a lot of them and see if those worked correctly or asking, oh, like some of the fun ones are is if you have an API that will let you add items to a list, add thousands and thousands of items to that list and then say, please send me the list. And if they don't do pagination, right, you can suddenly eat up all of the RAM or CPU on that API node and sometimes take it down. And the spooky thing, about application level DOS is these can be single requests. When I was at Rackspace, there was one particular system that if I made one really crazy request to it, it would fall over and die. So that's kind of spooky. These can be really spooky. In this sort of denial of service attack class, posture helps you, right? Because you can assume, you can assure that there's proper configuration where you're only exposing the necessary APIs, if nothing else, to help you limit that attack surface. Runtime can help you because you can see those floods in real time and react to them, particularly if you have whatever's watching the traffic, your runtime security tool knows how to talk to different pieces of infrastructure to call out to them and say, hey, kill this attack, kill this IP, block this person, push it through a CDN, whatever it takes. And then testing, right? Testing obviously can help because you can find these things ideally in pre-prod or somewhere before production, before they make it out. Now, the one thing that is interesting is these are very destructive tests. So you have to be very cognizant about where you do this testing. If you're in a better environment, in some of the better environments I've been in AppSec, I had the ops teams could set up miniature versions of what was in prod for me to test. This happened a lot at Rackspace. They'd set up a mini version of prod that I had free reign to be as nasty as I wanted it to because there were no customers using it, right? So the testing is interesting here, but it still can be very useful. Okay, data breaches, data leaks, right? My data's gone out the door. Those are another attack class that people are particularly concerned about. These are internal services that are made public, either because of a misconfiguration or a lack of an API gateway, or maybe something not going through an API gateway, maybe poorly written or no policy about APIs being public or not. You can also have excessive data exposure. This is the case where, unfortunately, a lot of the quickly get an API up and running programming frameworks do some magic for you, which from a productivity perspective as a developer is really cool. But from a security person is a bit scary because I will get a request in for, say, user. Well, I'll take the full user object out of the database and send that to the client and just let the clients pull out the 3 fields it needs, right? Now, if you control the client, that's fine. That doesn't matter. But attackers don't necessarily use clients. They talk to your APIs in manual ways to where they can just take all that data and go sell it in the, the dark internet or whatever that spooky, scary part of the internet is, right? So that's a problem. And then obviously injection attacks. So I could do SQL injection, command injection, all those other things. Ideally, I'm doing that as an attacker with the end goal of stealing your data. And then you can also have authorization and authentication, auth-N and auth-Z weaknesses, right? That allows me to either take over a client, steal a bearer token. BOLA is broken object level authentication, right? Where I, as customer 1, can just change my number and now make requests for customer 2's data, those kind of things. So all of these are quite ugly, and luckily all of these can be handled with posture. So if you're doing your API security posture correctly, you can detect those misconfigurations, as well as establishing policies or understanding where to establish those policies across your inventory of APIs. For runtime, obviously overly large responses or repeated requests for large amounts of data that are atypical will show up very quickly. And then obviously, if you're doing the correct kind of testing, you should hopefully shake out, if nothing else, the auth-N and auth-Z weaknesses to not have that kind of data leakage. And you'd also find, for that matter, the excessive data exposure type problems. Abusive functionality. So this is mostly what would normally just be called business logic flaws, right? Where I have a normal use case of my API, an attacker got creative and is using it for an unintended purpose, right? Suddenly your API is not working for you, it's working for the attacker. And generally speaking, automated testing won't find these. These are usually subtle things that take a human brain, or at least something that has the understanding of the business context of that API and its use case and how you can subvert it. Examples of this, If you have an API that sends out emails and you haven't done something quite right, I can use that to spam. And if I can generate emails by making calls to your API, I can have some fun if I'm a spammer. A denial of inventory is another attack. The idea here is I put things in a cart or somehow hold them, but don't actually go through to purchase. And if you don't have this set up correctly, I can deny people the ability to have or buy whatever inventory you have. The classic example of this was a theater that sold tickets. And the hack was to go put all of the seats except for the 2 for you and your date in the cart. You would actually buy your 2, and then you get a private showing, right? Good time. Carting is the way to, if you allow small transactions through your API, I can make some of those small transactions automatically or with automation through your API to validate stolen credit card data. And then ad fraud and evil SEO is, in essence, faking clicking or adding links to boost your page rank. And the OWASP is a good project, actually, that came out of California, if I remember correctly. Some of the people from the LA chapter, I think, were involved in this. The OWASP Automated Threat Handbook, it's not the newest project, but the data is still super valid in it. It's a great, interesting read if you're worried about these kind of automation of use of functionality attacks. In this case, really, runtime is the only perspective of API security that's going to help you here. Posture, not so much. Posture won't have the idea of context. It might help you sort of focus your efforts on what you test for business logic issues, because the understanding your inventory lets you sort of focus resources on the most critical to your business. But that would be manual testing. So that's also doesn't scale at all. We tried to do that at Rackspace, and we tested a lot of things, but we didn't test all the things because you just don't have that many humans. Never do. Okay, the OWASP also has an OWASP API top 10. And I thought, I've talked about these attack classes. Why don't I just run through the top 10 and give you an idea of where these things work or don't work. So broken object level authorization, the first one. Posture management, at best it can inform what to test, but it really doesn't help you directly. Runtime definitely does, and testing definitely does. Broken user authentication. Posture is another one. It could help you in that if you do your authentication at the gateway and you're not going through the gateway, that will tell you that, but that's almost more of a misconfiguration than a broken user auth. And definitely runtime and testing can help you there. Excessive data exposure, like we just talked about. Posture can help you there to make sure that you are going through those control points that could find this. So if you do have an intervening device like an API gateway or something that can help you there. Runtime definitely can help you to see those things and react to them. And obviously testing helps here. Lack of resource rate limiting. Obviously Posture can tell you this because it'll tell you if your APIs are using or not using that piece of infrastructure that is doing that rate limiting. Hopefully you're not doing rate limiting at an API level that's kind of too granular when you have those giant growths. To have every team have to do rate limiting is not particularly effective. Runtime will definitely tell you this because you can see those spikes and the lack of rate limiting. It's kind of unfortunate that's reactive, but it's there. And then testing can help you here as well. Broken function level authorization. Posture, again, doesn't really help you here because it doesn't have a context. This is where runtime can point out those issues in real time, or testing can also surface those as well. And the other half of it is mass assignment. Posture can't help you here. Mass assignment is an interesting issue where, let's say you have an update your email function in a web app, and you're supposed to send my, like say I would send my user ID in and my new phone number. Instead, I include other data, and your programming framework just says, whatever JSON I get, I will save it to the database as a data model. And so if I add gratuitous things like is an admin, or put a different email address and submit it in the right JSON form, your program will, or your API, therefore your program will just take it in and save it to the DB, or store that data somehow. So that's mass assignment. Posture doesn't help you here. Runtime definitely can, as well as testing. Security misconfiguration, it ticks all three boxes, right? Obviously, posture can tell you this. It's pretty easy to see if things are misconfigured. Some runtime tools will do what I would call passive scanning. So they just watch the traffic for things that are amiss and report on those as opposed to actively poking at a running API. And then testing obviously can help you here. Injection issues, not so much with posture. You might know where to focus testing efforts to avoid injection, but you wouldn't directly affect that. Runtime can definitely help you as well as testing. And then improper asset management is just kind of a giggle, because my idea of posture is inventory, and that's pretty much what improper asset management means. And then runtime can help you. Testing can't really help you. I mean, I guess it could help you if you find while testing that you have an API that you didn't miss, but that's really a gap in your posture, not a gap, not something that comes out of testing. And then insufficient logging and monitoring. Posture can help you here to make sure you're using whatever devices or infrastructure are needed to do that logging and monitoring. Obviously, runtime is that monitoring. So that's obviously you get the 3 checks in testing, not so much except for maybe proving that the logging works, because you're going to generate a lot of logs when you test. When I have a question, I've heard about zero security to zero trust. What does zero trust mean in API security? Well, I have a very biased view of zero trust because I used to work at Duo Security. So that's kind of my view of zero trust. I don't know that it has a huge impact on, a huge direct impact on API security, in that a lot of what zero trust for me was making sure that that human being that's interacting with the system was really the human being you expected it to be. That's what push notifications and those things give you. When you're talking program to program or software to software, they don't have a phone to poke to say, yes, it's really me. they're a program, right? And if you could poke a phone with the program, it would just poke a phone automatically for you, and you'd lose the value of that zero trust MFA kind of thing. I could see the concepts from zero trust of, where the traffic originates and what is generating that traffic, like what client. Like, I don't want curl to call my API, but a browser can. Those kind of things would be useful, but I don't see it as a great one-to-one fit. I think you could steal a lot of great ideas out of zero security and apply them to API security, though. And I'm all for that. Like, take good ideas and pass them around. Thank you for the question. So conclusion, I think I'm doing good on time. What are the key takeaways of this? Well, one thing, you're going to be dealing with the stakeholder soup when you're dealing with API security. There's lots of players here, right, that are all involved in making this stew happen, or the soup happen. So just be prepared to have to talk to a lot of different teams. And then secondly, keep complexity, right? APIs, they seem simple on the surface. It's really easy to think, oh, it's just like computer to computer talking across REST and JSON. It's not so bad. Yeah, but when you do it at scale and you would do it for real money and a real business, things get complex very quickly. There's loads of moving parts. So it's really easy to think that API is pretty straightforward, but there's a lot of nuances there that you have to consider, and I hopefully have talked about them. Perspectives. I think API security, you really have to look at from those 3 perspectives I mentioned, right? To take all of those into account to have a good API security program, or else you'll be focused maybe in one area, but not the rest, and you'll have some gaps, for lack of a better word. And then coordination is really interesting. Besides the complexity you get with the multiple IT systems, you're going to have to talk to a bunch of different people to make sure everybody's on the same page about where their responsibilities start and where their responsibilities end, and who has what when something happens. So there's a lot of coordination that has to happen to make these APIs work and work correctly. And then multifaceted, right? Protecting APIs really means talking about those 3 different things, talking about security posture, about runtime security, and about testing. When I see a couple questions come in, so I'm going to go to this slide and I'll answer those questions. Recommendation for any open source tool, SAST, DAST, IASP, RASP to get started. Zap is a great tool. for SAST, I almost like to start, if you haven't done any kind of SAST, I like to start with an SCA or a software composition analysis tool. So if you're internal and you can't, there's problems with using, you have no funding, let me put it this way, no funding, and there's problems with maybe sending your code off to a SaaS, dependency check, right? OWASP dependency check will give you that SCA view of your software. And a lot of times I honestly kind of like to pick a free and open source tool. Oh, SonarQube, thank you. That's a great one. Thank you. SonarQube is a great one. But I like to start with a free tool to see if that is even a problem you need to solve. And if it is, then it's time to say, okay, do we actually get budget for a commercial? And what's the delta between what we're doing with a lot of probably hand-holding in SAST and DAST versus paying a commercial provider, like open source versus commercial? What do you get? Do you break apart APIs down to services, dev level versus where they live on a higher level gateway API controls for easier consistency? So that's a really interesting problem. And there's a whole bunch, I can't remember, there's a really good talk actually from NGINX about different API deployment architectures, for lack of a better word.
Right.
And particularly when you do things like Kubernetes, you might have sidecars actually running a subset of what a gateway does with a master gateway that does the other things, but it can be really tricky.
Yeah, what I meant by that was, like, if you look at, like, you're taking a data source and exposing out an integration, right? Your API is typically an interface, but you might have a service, right? Point to point. And you like to see your data source integrations become stars, right? The same integration, right?
Correct.
I've often found that if I look at, like, the OWASP proactive controls and I try to align those to the development, I'm able to do some more consistently for all APIs at a gateway level, right? Where I have a known inventory, right? So I know the data class, I know where the exposure is, things like that. Things like rate limiting would be a good example, right? Or coarse-grained auth, right at the gateway, but not fine-grained auth. And then more of the other things are on the devs, right? Injection attacks are a good example, or data disclosure, right? There's always that dev that goes to the RESTful principles of not putting an account number in a GET request, right? That's always an argument. And so that's one I kind of push back to the devs, but I'm curious what your thoughts are on that one.
I agree with almost everything you said, if not everything you said. To me, the really interesting thing, well, let me put it this way. I can't imagine not running an API of consequence that isn't behind a gateway, for the reason that you just said about how you have coarse access controls happening at that gateway. I'm thinking about, if you have particularly if you're in a, like, Rackspace had every language known to man, almost. Do you have to write that many libraries? You can have every dev team that writes a different language make a new way to do auth that isn't handled already by your gateway. Like, it just seems like such a better control point to make those decisions happen from an effectiveness perspective. That, yeah, I would get spooked if I had a gateway of, an API of any kind of consequence that didn't have an API gateway in front of it, because a lot of the heavy lifting you can take off the devs back and get consistency, which is huge.
Right. Yeah. Because when you're herding cats at everybody wants to be in the API economy without a known inventory, right? Which a gateway provides you, you might have like 10 pricing services or customer services. And the easiest way to secure 20 of them, right? Make two of them.
Now, the one thing that's spooky about API gateways is those, like, early gen services that existed before the gateway that never get rolled up into the gateway.
Right. Yeah. Yep. But yeah, I've seen, like, a lot of service landscapes where they try to reduce the sprawl, and they do it by inventorying at the gateway level and then play catch up over time.
Yeah, and it's very unsexy. Inventories are not sexy things.
Nope.
No one probably got an attaboy from their VP for doing an inventory, but it just makes all your other decisions so much more informed.
Yeah, wouldn't it? Yeah, wouldn't
Yeah.
it be great if we had an inventory for log4j?
Yeah. Oh God. Yeah. Well, and like, so like a flashback to a log4j like thing. When I was at Rackspace, it was a really ugly RCE in Jenkins, and we had loads of Jenkins around Rackspace. Luckily, we were using a very early version of Defect Dojo before it was even released. It was called Test Tracker at the time. But inside of there, we had the technologies that were used by teams, which included things like Jenkins. And so we didn't get all of them, but we got 80 to 90% of them just by making a bit of a query into Defect Dojo to find out, okay, who's got Jenkins? Okay, let's go talk to those teams. Let's get it patched.
Yeah.
Right. That was huge.
Oh yeah. That's a great tool. I mean, we do the same thing for vulnerability management, and by default we get asset management to like throw into ServiceNow. But are there any that last question I had is really like around Defect Dojo. Are there any good API tool integrations with Defect Dojo that you can point out?
So there's two different ways that I would talk about API integrations with Defect Dojo. One is where Dojo calls out, and one is where others call in, right? So the call out is really right now, SonarQube is the big one. Cobalt, there's been some work to do the Cobalt integration. I'm not sure where that is because I'm not a customer of theirs, to be real honest with you. And there's another one that somebody was working on that I saw some PRs for that I'm forgetting. There's not a ton of those, but calling in, definitely. I've done a load of that work. And there's a couple of API clients for Dojo and Python. I wrote one in Go forever ago. But I like that because it allows you to put a shim between the thing and what Dojo is. Like when I was at Pearson several years ago, we had Dojo, we had checkmarks. Checkmarks at the time had a really awful way to do integrations. Like it was called their command line tool, which isn't all that awesome of an API. So we wrapped that in Python and made a Python script that knew how to call in and get results back from that knew how to actually fire off SAST in checkmarks. And then I had another service I wrote in Go that sat on the file system and watched for reports to be written. And when they were written, it would pick them up and ship them to Dojo. So like that kind of thing works really well. Unfortunately, it's not air quotes part of the project, but the API that the project has gives you that.
Yeah, I love Dojo because it allows you to swap out tools that are more fit for purpose without losing your process.
So you found the hidden feature of Defect Dojo, which, to be really blunt, was the ability to give a vendor the middle finger and swap them out and not be hurt.
Well, I don't mean that, right? Like, so
well, if I'm honestly though, that's why we wrote it. One of the reasons why we wrote it was to say, hey, like I want to be able to, if I get frustrated with my, I don't know, pick your thing, DAS tool, I can swap it out. And if I'm not using the mothership of the DAS tool for all my view of the DAS tool findings, my operations aren't really hurt.
Yeah. No, I get that. I mean, I do it more because I run into that one dev that did that Ruby implementation and my enterprise solution doesn't, work with it. And I'm like, you're doing some good things. I don't want to lose you, the person, your practice. So you can use your tool and onboard into my process with that. And it gives them another avenue. So it's kind of a win-win for both of us, right? I'm not forcing them to use an enterprise tool that's trying to cover all the things. I'm ensuring that those devs are doing the good thing, going out, looking up open source, like you said earlier, right? Finding free to provide value before you need to pay to get that value, right? Yep, that's a huge thing. But I don't know, I look at it through a different lens of glass, I guess.
Yep. Well, and we had that at RAC, which is one of the reasons why it was a multi-tool to begin with, because we had so many different languages. Some people are running Python, some people are running Java, there was Ruby, right? Yeah, and you just have to deal. And you can't find the best of breed tool that handles all languages. It just doesn't exist.
Nope. Yeah. Thanks.
Yep. I did see a question about how do you recommend handling sliding timeouts? I'm going to say, don't ask me. I've never had to implement those for real at any place. I've had to evaluate some, but that's different than implementing them. I would not rely on me, just to be blunt. How are we on time? I have no idea when this ends. Does
Yeah,
it end at
we're
3?
almost towards the end, so everyone's welcome to stay and continue the conversation. This is really, really great. Appreciate everyone's participation. Just wanted to shoot out a reminder about next month's meeting. Robert Hansen is going to be our guest speaker. I put the link in the notes in the chat window. Just please RSVP for getting the link to the Zoom meeting, and I appreciate everyone attending the calls, but not closing the call. The call is open. Please continue your conversation, and this has been really, really beneficial for everyone. Good, great conversation. And thank you, Matt,
Hansen's a
for
great-
taking the time to present for us. We really appreciate it on behalf of the board of OWASP Los Angeles.
Well, I couldn't get to go to, AppSec Cali, so this is the next best thing, right? Save me a flight.
Yep.
And Hansen ought to be great. Robert is super clever guy. He ought to be a really interesting talk next. I'll probably sit in on that actually, because
Yeah.
he's just fun to listen to.
Any other questions for Matt? Or if you want to share any news about other meetings that's ongoing, that's of interest, any groups that have started or
So yeah, I'll share some information. Hey everyone, I'm Ozon from the Israeli chapter. Unfortunately, we still have COVID here. We just got back after 2 years and had our first conference in person just a month and a half ago. The startup that is called the Piro, they hosted us. And now, unfortunately, we're back at home, but we are planning on having a really big conference. Moon Active, if you're familiar with the company, is going to host us. So we're planning on having something like 200 people in person and going to actually Zoom it live. So of course, we'll post it on LinkedIn and in all our channels on the Meetup website as well. And I will be glad to join.
okay, wonderful. If you have a link to it or a name that people can search for it on LinkedIn, please post it in the chat window.
Oh, thank you. Unfortunately, not yet, but we will have it soon. So
Okay,
probably we will see it because it will be on Meetup under OWASP Israeli chapter.
okay. All right, well, this recording is going to be posted on our YouTube channel. Look for it within a few days. And again, with 4 minutes left to the top of the hour, I know everybody's taking a lunchtime in Southern California or the West Coast, but anyone else joining us, we really appreciate it. Thank you for your time. Matt posted the link for the upcoming slide deck. And if there are no questions, comments, announcements, once again, thank you very much, Matt, for your giving the talk. Appreciate everyone's attending and great conversation. Have a great rest of your day.
Yep, thank you very much. I had fun.
Bye-bye, everyone.
Thanks, guys. Have a good one.
Thanks, guys.
Thank you, Matt.
Yep, I had fun.
Really?
Thank you very much.
Awesome talk. We miss you. So yeah, the weather here is perfect for AppSec Cali this week. But anyhow, I know we'll get back there soon.
Yep, I can't wait.
Yeah. Oh yeah, you and me. Yeah, there's a long list, but take great care. Really, you're looking good. Be well, be safe.
All right, take care.
You too. Take care, everybody. Thanks for
Bye, all.
joining us.
Hey, Matt, can you hear me?
I can hear you. Can you hear me?
Yeah.
Perfect.
All right. And I also gave you co-host rights, so you should be able to share your screen if you want to do a test run.
Yeah, let me do that right quick. I'm assuming you're cool with me killing your screen sharing.
Of course, yeah.
Yeah. Yeah, you know, just asked. I figured I should be, you know, at least ask before I do. Okay, so.
Yep, I can see the peeling the onion.
Yeah, perfect. And then this, you can see this as well, right?
Yep.
Perfect. My slide advancer works. So there we go.
Yep, all ready.
Yeah. not
And if
too
you
bad.
want to turn your camera on, that's cool with us as well.
Oh yeah, let me do that. Come on, bring down your little window. There we go. Oh, I need to actually, where is that? I'm gonna stop sharing for a second.
Okay.
This thing. Oh, it stayed. Okay, good. I wasn't sure if that was still there. My green
Yeah,
screen
it was.
behind me.
Yeah, so basically, closer to top of the hour, we're going to start just going through a quick intro for OWASP Los Angeles and OWASP, and then I'll hand it off to you. You can start your talk then. And you
Okay,
can
perfect.
take questions in the middle, or you can take questions through the chat window, whatever you're comfortable with.
Okay. Yeah, I've got a ridiculously big monitor. I'll fire up the chat window and leave it open and hanging around so I see them when they come in.
Okay. Sounds good. So I'll take the sharing back from you.
Yep. I guess you've gotten good at these things.
Yeah, they're nerve-wracking still, but yeah, I'm sort of have a routine.
Yeah, it's always interesting. You never know, like weird stuff happens.
Yeah, like initially, we play a short clip from OWASP. It's an introduction to OWASP, and oftentimes we used to lose the sound so nobody could hear it.
Nice.
Hey guys, good morning.
Morning,
My name
all.
is Saurabh. I'm new in LA. I was one of the chapter leads of OWASP Bhopal. I'm glad to connect with you guys.
All right, welcome. Welcome. Good to see you.
Thank you so much.
Hey, I'm from OWASP Israel chapter. I'm also part of No Names advisory board. Nice to meet you guys.
Okay. Welcome. Right, so recording is ongoing and I'm going to start. Everybody can see my presentation slide.
I see a picture of Matt.
Yep,
Yeah.
I see the slide.
Okay,